Europe is shaking. The power of nearly 100 active volcanoes rocks the continent to its core.
There's no reason to be less afraid of violent volcanic activity in Europe than anywhere else in the world.
Enormous and unstoppable, lava and ash spew from below the surface of the Earth, threatening to destroy everything in their path.
A lot of houses were swallowed up by the lava flows. They're gone forever. When you have 30 meters of lava on top of a house, it's over.
Europe is a hotspot of volcanic activity, and some countries have already paid the price.
After living through an eruption like that, you have to be prepared to make some changes and move somewhere else.
In September 2021, the Cumbre Vieja eruption wreaked havoc on the Spanish archipelago of the Canary Islands.
In terms of the amount of magma that came out, that was one of the largest eruptions of this volcano, and clearly actually the largest one of historic times.
Can disasters like this be predicted or prevented? Some high-risk European countries hope so. Italy is one of them.
Earthquakes are becoming more frequent, and the locals have noticed.
Etna, Stromboli, and Vesuvius present a triple threat of active volcanoes in southern Italy, and experts are worried.
The Phlegraean fields are the real big, risky guy that we have in Italy, and I would say in the Mediterranean region.
Where volcanoes stand, surveillance is crucial. In Germany, a dormant volcano may one day shake itself awake.
The Lacher Sea is the result of a massive eruption that shot a column of ash, lava bombs, and giant blocks of stone 40 kilometers into the sky. They fell as far away as France.
Are dormant volcanoes ever really dormant? Why is continental Europe home to some of the most active volcanoes on the planet? And where is Europe's greatest risk? Is monitoring these volcanoes ever enough? Through interviews with European volcano experts, computer-generated imagery, and unprecedented aerial footage, we are about to dive deep into one of the most impressive and destructive spectacles that nature has to offer. From Iceland to Italy, Germany to Spain, Europe is dotted with volcanoes. How much should we fear living in their shadow? A volcanic eruption is an unforgettable sight, as anyone who's ever witnessed one will tell. It's one of the most fascinating, most incredible phenomena on the planet.
The Earth is kind of like a combustion engine. It has a lot of heat stored up inside underneath its crust, like a pressure cooker. If there's no way for that energy to be released, it will explode.
Volcanism is one of the ways that heat is released, and this release can only take place in certain places and certain ways.
The scope of volcanic eruptions is far greater than the human scale. 800 million people in the world live less than 100 kilometers from an active volcano and must coexist with the threat they represent.
There are 1,670 subaerial volcanoes in the world, but just because a volcano is active doesn't mean it's erupting. In reality, of those 1,670 exposed volcanoes, there are around 60 eruptions each year.
We have lots and lots of people live close to volcanoes. So we live with volcanoes, and some of that volcanic activity can lead to disasters and loss of life.
On a planetary scale, over the last 500 years, nearly 300,000 people have died as a result of volcanic eruptions, and Europe has its fair share of deadly volcanoes.
Continental Europe, which doesn't seem that large of an area when you fly over it, sees regular, sometimes intense volcanic activity. It's a far cry from being an old continent where all the volcanoes are extinct.
Over the course of history and the prehistorical period, there have been some absolutely catastrophic eruptions in the Mediterranean basin, just as large as any of the other eruptions in the rest of the world. There's a volcanic activity in Spain, in France's Massif Central, west of the Alps, where the Alps curve. There's volcanic activity in Germany. The Alps continue into Eastern Europe, and there's also volcanic activity there along the Alpine region into Poland, Slovakia, and Hungary. There's no reason to be less afraid of violent volcanic activity in Europe than anywhere else in the world. It's just that these potential major disasters happen considerably less frequently.
As a result, we tend to forget the threat posed by other volcanoes. Those we think of as extinct, but which span the entire continent. The most famous among them are here, in the Chaîne de Puy in Auvergne.
The last time an eruption took place was less than 10,000 years ago, which is recent enough for the entire mountain range to still be considered active.
Could these volcanoes wake up again one day? For now, that's a possibility that can't be ruled out.
Volcanic activity here began more than 100,000 years ago, and the last eruption took place just 8,000 or 8,300 years ago, which is nothing on a geological scale. That means that the Chaîne de Puy is still on the world list of active volcanoes. It's not active, but it's not extinct either.
If it happens in the next few decades, it will affect us directly, and that's not out of the question. No one can say there won't be an eruption in the Chaîne de Puy 30 or 40 years from now.
One of the last eruptions to strike continental Europe was also one of the most spectacular. It made front-page news for several weeks and left a trail of destruction in its wake. An ocean of ash covered a vast expanse of land. This lunar landscape seems to be frozen in time after the Cumbre Vieja volcano erupted for 86 days straight. The island of La Palma in the Spanish Canary Islands has been permanently disfigured by this unprecedented disaster.
There will always be a before and an after on La Palma.
In terms of roads, there used to be a main one from north to south. Now, the north and the south are cut off from one another. The only way to get there is by boat.
The ash swallowed up all kinds of essential infrastructure. A lot of different networks were affected. The water supply network and treatment facilities, which were underground, are either completely destroyed, in need of renovation, or experiencing long-term pollution.
A total of 7,000 people had to be evacuated urgently. 3,000 buildings were completely destroyed. It will take decades to erase all the traces of this major eruption. Yet the local population have no choice but to watch, powerless, as this phenomenon unfolds.
It's a very active archipelago, meaning that rarely do 50 years go by without an eruption. The only question is, where will it be? Will it be on an island like the big islands of Tenerife or La Palma? Or a smaller one, like El Hierro?
The Canary Islands are composed of 7 islands, all volcanic, and have a population of more than 2 million people living among this incredible density of volcanoes. The origin of this stunning scenery, forged by a series of eruptions, is a mysterious heat rising from the depths of the earth, where it comes from remains totally unknown.
Volcanic activity in the Canary Islands doesn't follow the edges of the tectonic plates, as it does in the Ring of Fire in the Pacific, for example. It's what's called a hotspot. A hotspot is a thermal anomaly anchored deep in the earth in the mantle.
This heat anomaly melts the rock in the Earth's mantle, which then breaks through the crust in a way that's completely independent of the edges of the tectonic plates. What makes hotspots unique is that they're stationary compared to the center of the Earth, unlike tectonic plates, which move around on the surface.
It's a bit like a sewing machine in reverse. It pokes a hole in one spot, creating a volcano. Then the plate moves, and hundreds of thousands or even millions of years later, a second volcano will appear a bit further off, then a third and a fourth.
The last large-scale eruption on the island of La Palma took place in 1585. There had been practically no activity since. Until that day in September 2021, when the fate of the island would forever change. A dark day for the 85,000 inhabitants of the Spanish island. Over the course of 24 hours, they experienced nearly 3,000 earthquakes.
An earthquake is the Earth moving. Why does it move when an eruption is taking place? Because the magma stored kilometers or dozens of kilometers under the Earth's surface begins to move for a variety of reasons. And that magma tends to rise to the surface, breaking rocks along the way. The breakage of these rocks causes earthquakes. That's how we can track the movement of the magma from dozens of kilometers underground all the way up to the surface.
I describe it as an old country house, to which you haven't been in ages. When you turn on the faucet, water comes out, but it comes out in fits and bursts, and it makes weird noises. It's the same with volcanoes. If there's seismic activity, what we call a tremor, it means the liquid is rising at a high enough speed to reach the surface. In that particular case, we saw all the signs, and then it erupted. At approximately 3 o'clock in the afternoon on Sunday, September 19th, there was a sudden explosion with plumes of ash rising several hundred meters into the sky. A massive fissure appeared, several hundred meters in length. That's often how it begins. It can last for weeks or months. We estimated it would last between 3 weeks and 3 months.
There was a very big plume of ash that rose 3 or 4 kilometers up into the air, hence the huge quantity of ash. When you have a 15 or 20 meter wall of lava moving slowly towards you, like an enormous bulldozer, you take what you can and get out of there as fast as you can. But your house will be covered in lava and destroyed.
Flows of molten rock hurtled down the slopes of the volcano at high speed. Nothing could have stopped them.
A lava flow is an amazing sight to see. It's literally a river of molten rock, which is very viscous, because it also contains gas, since the Earth is essentially degassing. It moves along following the pull of gravity and takes over low-lying areas such as former valleys and the like.
The lava was very hot and very fluid. The temperatures reached as high as 1,250 degrees Celsius, which is very hot for a lava flow. It's among the highest we've ever measured. Because the downward slope, the lava flow reached speeds of up to 700 meters per hour, which is very fast. They had to take emergency measures immediately, which is to say evacuating people to safer areas a few kilometers away.
Bit by bit, the lava flow took more and more ground, moving across the western part of the island at an alarming speed. By the 10th day of the eruption, it had reached the sea. But the volcano wasn't done yet. How far would the lava go? And when would the craters close back up again? No one could say. The answer finally came in the form of a Christmas present. On December 25, 2021, the eruption was declared officially over. It had lasted a total of 85 days, making it the longest eruption ever recorded in the history of the Spanish archipelago.
There's no reason for volcanic activity on El Hierro or La Palma, the two most recently formed islands in the Canary Islands, to stop in the near future. On the contrary, the islands are still being formed and will continue to do so for millions of years.
Even if the next eruption takes place in 50 or 60 years, people aren't going to wait. Some people may decide the island is cursed and it's better to move away. But most of the inhabitants love where they live and want to go back to living there, so they'll rebuild.
The Cumbre Vieja eruption did a substantial amount of damage, more than 900 million euros worth in total. It serves as a valuable reminder that Europe is never safe from a major volcanic event. The threat of an eruption has always weighed on the continent and has terrified the human race since the dawn of time. "2,000 years after Pompeii, the Neapolitans, who live at the foot of the mountain, still call it the exterminator. The perfect cone of Mount Vesuvius casts a threatening shadow over the city of Naples and the entire region. It's the quintessential volcano in southern Italy, and possibly one of the most famous on the planet.
Everyone who lives in Naples is attached to Vesuvius. We've given it a nickname here. We call it the Neapolitan Mountain. Vesuvius generally has long periods of inactivity. Its last major eruption dates back to 1631, which was quite a while ago. So we tend to forget that it still poses a threat, and to only remember the good things about it.
However, over the course of its history, Vesuvius has taken thousands of lives. As Pliny the Younger, a writer and politician of ancient Rome, wrote when he described the volcano's most famous eruption in detail.
The first written description we have of a volcanic eruption was Mount Vesuvius in the year 79 AD. That was the first chronicled scientific account of a volcano erupting.
Frequent sizable earthquakes shook the houses, which seemed to be torn up from their foundations and were swaying back and forth. Outside, pieces of pumice, a lightweight porous stone, were falling from the sky.
This was in 79 AD. After an 800-year slumber, Vesuvius violently woke up, wiping the cities of Pompeii and Herculanum off the map.
The eruption that took place in 79 AD was the largest possible eruption of Mount Vesuvius, the worst-case scenario. It couldn't have been any more catastrophic than it was.
The eruption lasted for 19 hours, from 1 p.m. on October 24th until 8 a.m. on October 25th. It destroyed a lot of cities. It didn't last long, just 19 hours in all, but that was enough.
A massive cloud of volcanic ash, gas, and rock was shot more than 32 kilometers into the sky, 25 times as high as the mountain itself. This lethal plume bombarded the surrounding area for almost 18 hours, making the lives of the locals into a waking nightmare.
It was a combination of hot volcanic gases, ash, and pumice. And because of how hot that combination is, since volcanic gases can reach 900 to 1,000 degrees Celsius, it's lighter than the surrounding air, so it rises up into the sky through a phenomenon called convection. That's how it got 10 to 20 kilometers up into the air.
On Pompeii, there was a fallout of a few meters of ash that has been falling all the time by this eruptive column.
We know that during the first phase, which lasted around 12 hours, the inhabitants of Pompeii died because the roofs of their houses caved in. The pumice and ash shooting out of the volcano were very heavy, so it took just 20 centimeters to make the roofs collapse. Even modern-day houses wouldn't be able to withstand the weight of 20 centimeters of pumice.
And it wasn't over yet. The eruption was about to enter into its second phase, which would be even more devastating and take even more lives. A pyroclastic flow.
There will be a moment in which the strength of the gas going up is not enough to maintain all this ash, which of course represent a very large load. And there will be a point in which these eruptive columns will collapse.
It's like an avalanche, but instead of being an avalanche of snow, it's an avalanche of volcanic gas and ash, which can travel at very high speeds. It can reach speeds of 500 to 600 kilometers per hour. These flows are extremely dangerous because they reach very high temperatures that can kill you instantly. The inhabitants of Herculaneum and Pompeii died because of the thermal shock. They were carbonized by the Nuée Ardente, which was at 500 degrees when it reached Herculaneum and 200 to 300 degrees by the time it reached Pompeii.
Every living being in its path was instantly cooked. The pyroclastic flow was also carrying massive blocks of stone along with it because it picked up everything in its path. Pyroclastic flows are by far the most dangerous and the most destructive part of any volcanic eruption. Nothing can resist a pyroclastic flow.
It was an extremely violent phenomenon, one that could be compared to an eruption filmed nearly 2,000 years later on the slopes of Mount Unzen in Japan, which killed 43 people. In 79 AD, the sudden, powerful eruption of Mount Vesuvius left no chance for survival. 15,000 people died, 2,000 of them in Pompeii alone.
Of course, we cannot be sure 100%, but it is very likely that an eruption like this will occur again. We don't know when. We don't know when, of course.
We don't know if it will be during our lifetimes or those of future generations, but we're bound to see more eruptions in the future.
Volcanologists know that far below the surface of Mount Vesuvius, the next eruption is already in the works.
We know there's magma 8 kilometers below the surface. That magma chamber is no longer connected to the exterior. So, in order for a new eruption to take place, the magma will have to find a way to the surface. To that end, it must overcome the pressure of 8 kilometers worth of rock on top of it.
When a volcano degasses inside, the gas wants to get out. But for rheological reasons, which means due to the mechanics of the rock, it can't. Obviously, the pressure inside the mountain will increase. It's a bit like a pressure cooker, and if one day the mountain finally breaks, it could cause a cataclysmic eruption.
If this worst-case scenario were to take place, the authorities would have absolutely no choice.
It's a very densely populated, very urban environment. There are almost 4 million people living around Mount Vesuvius, some of them very high on the slopes. People are going higher and higher up to find empty land, so when it erupts, which it definitely will, it's going to do a lot of damage.
Until just a few years ago, there was only one lane to evacuate 40,000 people with a single freeway ramp, which would have been completely full in the case of an eruption. People would have had no chance of escape.
Obviously, if you want to be able to evacuate 3 or 4 million people, you have to know pretty far in advance. Another very important part of risk perception is being able to tell people how sure you are that an eruption is about to take place.
Let's say it's going to erupt. If it's supposed to happen 5 years down the line, it will pose a challenge for politicians who will have to deal with it when the time comes. But if it's not going to happen for 1,000 years, there's no urgency. So the government is playing poker with the lives of the local population because there's a lot of money at stake and they don't want to spend it on a risk that's not immediately perceptible since it seems so far off.
With its perfectly conical shape and crater on top, Vesuvius looms over the city of Naples as an obvious threat. But there's another threat that's much more subtle, almost invisible. It's here, very close by, and it's a much greater source of concern for the area around Naples and all of southern Italy. Just a few kilometers as the crow flies from the top of Mount Vesuvius, on the other side of Naples, lies another volcano. Experts consider it to be one of the most dangerous on the planet. You've probably never heard of it before. It's called the Phlegraean Fields.
Phlegraean fields are the real big guy of the entire situation. It's much more dangerous than Vesuvio, because Phlegraean fields is not just one single spot volcano. It is a group, it's a volcanic area spread on a vast region.
These volcanoes have enormous magma chambers. They contain not just a few cubic kilometers, but hundreds or even thousands of cubic kilometers of magma below the surface of the Earth.
We don't have the impression to be on a high mountain spitting fire, just like Mount Etna or Stromboli. We don't see Phlegraean fields like a volcano.
To get an idea of the sheer scale of these volcanoes, which are nearly invisible from ground level, one has to go up. This is the result of the largest volcanic eruption in Europe in the last 200,000 years. A massive crater 13 kilometers across, partly submerged beneath the waters of the Gulf of Naples. It's called a caldera.
So these are the Phlegraean fields. They're 12 kilometers across, and this is the edge of the caldera. Inside the caldera, there are other, smaller volcanoes, around 70 in total. Part of the caldera is underwater, so this chunk of the Gulf of Pozzuoli is also part of the Phlegraean fields.
A caldera is a gigantic crater caused by the collapse of an entire volcano. What causes that collapse? The emptying out of a magma chamber.
Il est dû à la vidange d'un réservoir de magma.
What happens when a magma chamber empties out? It creates a void underneath, so the upper part of the volcano collapses into that void.
The Phlegraean fields are a large crater, like a sort of cauldron that sank something like 700 meters down, so it's huge. It's colossal.
The eruption that formed this caldera took place 40,000 years ago. It was a massive explosion that shot huge amounts of volcanic material into the air, landing as far as Russia, some 2,500 kilometers away.
There's never been an eruption like it on the entire planet in all of history. We've never seen hundreds of cubic kilometers of material projected into the air. It hasn't happened on the surface of the globe for several thousands of years. It was really what we'd call a cataclysmic eruption. The eruption of the Phlegraean fields 40,000 years ago was truly cataclysmic.
What makes something a super eruption is that when it releases a massive amount of ash and gases into the atmosphere, it can alter the climate on a global scale. We believe an eruption like this contributed to the extinction of the Neanderthals.
The result of this cataclysmic eruption was a volcanic megastructure, the likes of which have rarely been seen in the world. Today, there are 500,000 people living inside the caldera, and 3 million people are directly threatened by this gigantic volcano. If another major eruption were to occur, half of the Gulf of Naples would be wiped off the map in a matter of minutes.
If an event like that were to happen in southern Italy, the economy would come to a complete halt. We're not talking about just 1 or 2 meters of ashes. There could be as much as 50 to 100 meters of ashes on the ground.
Consequently, it's very important that we monitor volcanic activity all around the world so we can predict and prevent the risk of volcanic activity.
The kind of explosion can be very harmful because they can produce a particular kind of explosion that are called blast, in which the expansion of gas can launch the ash at supersonic speed, up to 2 times the speed of sound. Of course, you can imagine with this kind of powerful eruption, nothing could survive. Nothing could survive.
The last time the Phlegraean Fields erupted was in 1538. This is the scar it left behind, the Monte Nuovo crater. That was nearly 500 years ago. Since then, nothing. However, scientists are convinced that the volcano isn't done erupting. In fact, the Phlegraean Fields may already have started to awaken.
Between 1982 and 1984, the land rose by nearly 2 meters, and that lifting was accompanied by a large number of small earthquakes. There were more than 15,000 tremors over the course of that period. After 2 years of rising in elevation, the land sank back down by 90 centimeters. And since 2005, it has slowly been rising again.
This is evidence that there is a magmatic system underground, that there is a breathing system underground, and that this system is occasionally being recharged from below.
The city is permeated by a strong smell of sulfur. The solfataras, or burning smokestacks, are constantly releasing toxic vapors.
Now the point is, will be the system good enough, permeable enough to let all the gas come through? Or the system will not be permeable enough to let this flux be exhausted, and therefore there could be an accumulation of gas that could bring to a new eruption.
As temperatures rise and gas levels change, we're going to have to start asking ourselves some serious questions about what's happening and on what scale of time. Should we be worried about something happening 50 or 100 years from now? Or sometime in the next few months or years? That's what we're asking ourselves now.
There are more and more earthquakes happening, and the locals have noticed. They're slowly starting to come to the realization that they live inside a volcano. The problem is that we don't know exactly how much time we have. When will we be able to say with certainty that an eruption is about to happen? How much time will we have? That's why we need to work on preparing evacuation routes and preparing the population so they'll know exactly what to do. We'll have no time to waste.
Everyone here knows their fate lies in the hands of a volcano. Whether it be the Phlegraean Fields west of Naples, or Mount Vesuvius to the east. Faced with this threat, the whole region is closely monitored, especially since there are other volcanoes threatening the Mediterranean. The Greeks and Romans believed that it was here that Hephaestus and Vulcan forged the weapons of the gods. Mount Etna, one of the world's most active volcanoes, is capable of erupting several dozen times per century. It's the largest volcano in Europe. The highest point reaches an elevation of 3,350 meters, and it's massive. You'd have to hike for 3 days and 3 nights without stopping to walk all the way around its base.
Mount Etna is not just a simple volcano. It is a volcanic area or a volcanic district made of several eruptive centers. And when I say several, I mean at least 200. 200 volcanic centers which are still visible and visitable, just like the one that we are seeing in this moment, which is a small monogenic crater erupted along one tectonic fracture oriented more or less north-south, which is the main tectonic line which allowed the magma to come through from the mantle all the way to the surface. This structure here, this tectonic line, is one of the many that constellate the entire region of Mount Etna.
There are several summit craters at the top, either 4 or 5, depending. Mount Etna changes shape. The elevation and the number of craters change from one visit to the next.
We think there is multiple magmatic reservoirs underneath Etna that are feeding each other and feeding different vent areas, different eruptive craters that have formed over the last, centuries.
The activity of Mount Etna occurred between 80,000 years ago and 15,000 years ago. So Mount Etna is a very recent volcano. It grew in a very limited lapse of time, and it grew with an enormous volume. Consider that Mount Etna has a volume that can be estimated around 370 cubic kilometers.
There are nearly 1 million people living on the slopes of this monstrous beast. Catania, the second largest city in Sicily, lies at its base. It still bears the scars of 2 major disasters that took place in the 17th century. The eruption of Mount Etna in 1669, and a devastating earthquake just a few years later in 1693.
The eruption 1669 was very destructive for the countries, the country fields, but there was no one victim. The earthquakes of 1693 was instead very, very destructive for human lives. Out of 3 people from Catania, 2 of them died. So we estimate that the population was around 30,000 people and about 20,000 died in the earthquakes.
Sicily's history and the lives of its inhabitants have been marked by Mount Etna's temper ever since.
We have had eruptions that lasted for 6 months, 3 years, and even 10 years. So long, long-lasting eruption, and you would see just a slow-moving lava flow with an output rate of a few cubic meters per second, from 1 to 5 cubic meters per second. And these eruptions can really last for several months, as I told you, even years.
But that's not all. Some scientists are also worried about its gigantic southeastern flank. Facing the sea, this slope is a weak point, slowly sliding along unstable soil. A recent study concluded beyond any doubt that this immense volcano is gradually slipping into the Mediterranean.
It's okay for now because it's happening very slowly and no one can tell. The inhabitants of Giare and the other cities at the base don't pay it any attention. But if a large eruption were to take place, or if a large earthquake were to destabilize the area, the whole eastern flank of Mount Etna would slide into the sea, causing an enormous tsunami.
If that were to happen, it would take just minutes, because the Mediterranean isn't very big for it to affect the entire coast and hundreds of thousands of people. We're talking about the French Riviera and the Italian coastline, but also on the African side, in Tunisia and Algeria.
This threat impacts everyone living near the Mediterranean coasts. But there are other places in Europe, well inland, that could be affected by a different kind of threat, without even knowing it. This bucolic region is composed of lakes with near-perfect outlines and hills as far as the eye can see. This is the Eifel mountain range in southwestern Germany, just a stone's throw away from the German borders with Belgium and Luxembourg. This stunning backdrop is a paradise for lovers of the outdoors and hiking.
What makes the Eifel mountain range unique is that it's dotted with small lakes, some of them measuring 1 to 2 kilometers across.
Looking at this grass and the cows, you wouldn't think it's a volcano or that there's an impending eruption.
Nevertheless, this scenery, where time seems to stand still, was witness to a cataclysmic eruption. This is what remains of it. The Lacher See, or Lake Lac, a crater lake. It was formed nearly 13,000 years ago when the last volcanic eruptions shook the region and destroyed all forms of life.
The Lacher See was the site of a major eruption that projected a column of ash, lava bombs, and blocks of stone up to 40 kilometers into the air, which landed as far away as France, beyond even the Loire Valley. It impacted a large part of Europe.
And that Plinian eruption brought then ash all the way to Scandinavia and southern parts of Europe as well. Larger eruptions in the last 15,000 years in Europe.
This lake was created by a cataclysmic event that affected the climate of the entire northern hemisphere. As the magma rose to the surface, it came into contact with water, causing massive explosions and the formation of what we call a maar.
A maar, M-A-A-R, is formed when magma rising to the surface comes into contact with either an underground river or the water table, resulting in what we call a phreatomagmatic eruption.
This causes a crater to suddenly appear at the surface. The walls collapse and fall in on themselves, causing another explosion.
Once the eruption is over, since it takes place at the site of a water table or a river, the gaping hole left behind by the violent eruption quickly fills back up with water, creating a pretty lake.
A hollow crater is formed. These kind of lakes often have very straight walls. You can have a lake that's 2 or 3 kilometers across and up to 200 or 250 meters deep.
Could a cataclysmic event on such a scale happen again one day? Is there a risk of these sleeping volcanoes reawakening in the heart of Europe? Scientists have tried to answer these questions.
We used data from GPS stations all over Europe. We were interested in the part of Europe that goes from Spain, France, England, Germany, Poland, into Scandinavia. The part of Europe that tectonically is considered to be stable. It's not affected by the collision of Africa with Europe.
One large-scale scientific study reached a definitive conclusion. Something is happening deep underneath the Eifel Mountains.
Most of stable Europe is subsiding, it's going down, And that has to do with the Earth still adjusting from there being ice in Scandinavia in the Ice Age. But what we saw was there was one area that was doing something opposite. It wasn't going down, it was going up. And that made this an unusual feature that could not be explained easily.
It shows that things are moving, that the mantle is moving bit by bit, and that there might be magma moving around, which means the volcano's not extinct, and we knew that already. It's too young, it's dormant, and we have no reason to expect it to awaken soon, but we can't cross it off the list of active volcanoes.
The changes at the surface are unprecedented in scale. And what's more, they're perfectly centered directly below Lake Lach.
It's the only place that we know is volcanic. So the volcanic activity is in the place that moves up the fastest. And what we found was this could be explained by there being a plume underneath, and that plume is pushing upward. And this means that the Lac Azé area has hot mantle underneath it at a certain depth, exactly we don't know.
Molten magma searching for a path to the surface. A path it just may find one day. All of this is happening less than 100 kilometers away from 5 of Germany's largest cities.
A lot of people live in that part of Germany, in neighboring Netherlands, Belgium, Luxembourg, France. This is an important economic area. And to think that in the middle of all this, there is a mantle plume pushing its way upward, warming up rocks that migrate closer to the surface in an area that we know in the past had explosive volcanism is something to be aware of.
Meanwhile, the Eifel Mountains, a UNESCO-listed heritage site, continue to attract visitors who are drawn to the wild, pristine landscapes. Nothing on the horizon seems to hint at the fact that there are volcanoes sleeping beneath this part of Germany. But there are other places in Europe where the volcanoes are much less discreet. Lands where lava and ashes are nearly constantly erupting out of the soil. Iceland, a land of fire and ice. It has more active craters than any other country in Europe. With an incredible 32 volcanoes in an area just 1/5 the size of France. Here, a major eruption takes place every 4 years on average.
Iceland is coinciding with a mid-Atlantic ridge, right? There is generally the kind of opening of the Atlantic Ocean that is going through that part of Iceland, but it is also a hotspot, a plume.
That leads to the production of a lot of magma because of the convergence between the two phenomena, so it produces a lot of magma, resulting in many volcanoes and some very large eruptions.
On a human scale, people from Iceland are used to volcanic activity, which is generally for the best.
In this lunar landscape filled with volcanoes, there is one with a name that is nearly impossible to pronounce. Eyjafjallajökull, which has only erupted 3 times in the last 1,000 years, leaving a quasi-negligible mark in the history of volcanoes. And yet, on March 20th, 2010, its awakening did not go unnoticed. Eyjafjallajökull was about to become one of the most famous volcanoes on the planet.
The eruption started out fairly normally with what we call a fissure eruption, slightly outside the center of Eyjafjallajökull, resulting in some impressive lava flows. It was an amazing sight for people living nearby. Many Icelanders came to enjoy the show, and there were also tourists from all over Europe and all corners of the world.
It was a very classic effusive eruption with hot, flowing lava and very little explosive activity.
People were taking pictures and enjoying the view, but it didn't remain calm.
Suddenly, on the 25th day of the eruption, a flow of magma managed to make its way to another area that had until then been spared: the summit of the volcano itself.
What's special about this volcano is that it's covered in a glacier. There are more than 200 meters of ice on top of the volcano. So what happened when the magma reached the surface? It vaporized massive quantities of ice, turning ice into water and water into steam. 1 cubic meter of liquid water becomes 1,000 cubic meters of steam, so it's a huge increase in volume.
It caused a very powerful explosion. The contact between cold and hot resulted in violent fragmentation of the magma.
As a consequence, it caused much smaller particles of ash, which could therefore rise much higher into the sky and spread across far greater distances.
The result of this massive explosion? 1,000 tons of ash were powerfully shot into the atmosphere each second, reaching an altitude of 11 kilometers, the exact cruising altitude of commercial aircrafts.
If a commercial aircraft were to fly through a cloud of ash, the cockpit windscreen would become completely opaque in a matter of minutes. There would be no light coming in the window, and secondly, the ashes would get into the jet engines.
If volcanic ash were to enter an aircraft's jet engines, those ashes would melt and form magma. So you can imagine what would happen if there were magma inside an engine, or at the very least, you can assume it would not be a good thing.
The risk is that the engine might simply stop, causing the airplane to crash. So Europe had no choice but to make a radical decision.
Out of precaution, all air traffic across Western Europe was brought to a halt. It cost a lot of money. Tens of thousands of flights were canceled, resulting in massive, instantaneous economic losses. There were around 6 million travelers stuck on the ground, unable to fly. 63,000 flights were canceled.
This crisis caused colossal damage to the global economy. $5 billion in losses due to the complete halt in air traffic. Much worse than the financial impact of the September 11th attacks. This eruption, which affected the entire continent of Europe, proves that volcanoes are perfectly capable of intensely destabilizing our fragile balance and seriously affecting the everyday operations of today's society. But Europe is also a very densely populated continent. A large eruption could cause countless victims. The risk is real. In some cases, it's even extremely high. All that's left for us to figure out is if it can be predicted, because the threat of a volcanic eruption comes with a very large unknown: our own ability to respond if such a situation were to arise before it's too late.
Evacuation of people is something that involves human nature. Are they willing to leave? Are they willing to respond to a call from the authorities? Do they have to leave something behind? So there is the human element in that kind of question that is much harder to assess